Hello, welcome to Arizona State Team 16 Senior Capstone Design Demo video. My name is Delano Dunbar. I'm going to be representing Team 16, which consists of Jamie Cummins, Trent Molson, and Anastasia Murr. For our capstone project, we participated in the inaugural Solar District Cup Collegiate Design competition. Basically allowed teams all across the nation to design, plan, and analyze solar solutions for different profiles and cases that they offered. Now, what we used for our design was the Aurora software, a really robust software that allowed us to go in and design for each of the building structures or land areas that we had for Ball State University. We were able to go in and identify that particular consumption profile for either the building or a total consumption profile in the case for the entire campus, which we used for the final ground mount installation. Now you can see for this ground mount installation, we went through and uploaded all the utility provider information to get an accurate representation of the electricity usage throughout the entire year, also its hourly consumption as well. Once all that information is put in, we were able to go in and actually design our solution here. Now, Aurora is just for the solars and inverters and other electrical components. Once we decided on which solar panels that we were going to use, which were the sun power panels, 470 watts. This particular ground mount installation has 8,633 panels for this 13-acre area. Through Aurora, we're able to simulate the effects of these panels and the solution. You can see here the system losses, DC, AC, and we're able to get a robust, detailed result of how that's the performance of that solution as well as its financial return. Through Aurora, we're able to change some of the design settings, the weather maps, and just kind of adjust some of the simulation settings. Ultimately, we were able to produce financial outputs from Aurora as well. As we were going through our design, we were going through several different iterations here. What you're seeing now is the Robert R. Emers building. This was one of the buildings that had several small rooftop areas, but you can also see a lot of obstructions. So that was probably our biggest challenge there. The Bracken Library had a lot of small areas as far as the rooftop. So it made it very difficult to kind of string some of those modules together and get a design or a solar solution that we felt comfortable with. So again, just these small patches of the rooftop was probably one of our biggest challenges there. Now the Doherty complex, you can see the pitch on this rooftop made it especially unique to try to design a solar solution for. We did our best and just kind of played around with it. Really, throughout this design competition, it was more of a trial and error. Hey, let's see how this panel works with this inverters and, stringing different things together. The First Presbyterian Church was probably one of the more straightforward buildings. In Aurora, it has a LiDAR tool, so you can scale the rooftops accurately as they're represented in real life, as well as the trees. That's one thing that we made sure as we're going through our designs is how we're going to impact the area and community around us is something that we took into consideration. This is the No Area Complex. Now, we really thought there was going to be a lot of great potential for this particular building. As you can see, there's a very long rooftop service area, not a lot of obstructions on the rooftop, and the trees didn't really come into play or weren't a factor when making that design. Ultimately, we were able to complete with the Robert Bell building, which is kind of our go-to when it came through this solar design. Is when we went through our different iterations, we wanted to focus on one particular building, get it right on one building, and apply that same concept to the rest. Ultimately, we had a great time doing this competition. There were very few teams that actually completed the competition and did a final presentation, so I'm very proud of Team 16. We learned a lot, and I hope you guys enjoy this video. Thank you.